Good morning, good afternoon, and good evening, everybody. I'm Xiaowen Zhen, the coordinator of this current webinar series, Air Pollution and Human Health. And actually, last month, we have presented 4 lectures on the section 1, the air we breathe. And today, we are going to move to section 2, outdoor and indoor air pollution. And the 5th lecture is the health effect of indoor particles exposure and the intervention. Before starting the lecture, I would like to give a short introduction of our honor speaker, Professor Zhuohui Zhao.
Hi, good evening.
And Professor Zhao is currently an associate professor at the School of Public Health, Fudan University, Shanghai, China. She got her PhD degree from the Zhuohui University, Switzerland. And her research interests include air pollution, particularly indoor environmental exposure and health, and also the environmental exposure and childhood health. So far, Professor Zhao has published 50 publications. And let's welcome Professor Zhao, and I'm gonna hand it over to you.
Thank you. So good evening, good morning, and good afternoon. Very nice to meet you online here, and it's my great pleasure to give this speech about the health effects of indoor particles exposure and intervention. So shall I share my screen now?
Oh, I should stop it.
Okay. So now you should, okay. Okay, this is the outline for my talk today. It's going to be majorly 4 parts. And I think it's about 45 minutes, and then we can going to have 10 to 15 minutes for your questions. Yeah, this is a general picture about the particles. This is around almost 20 years ago, or between 20 years ago to 10 years ago. So this is a global distribution of the PM2.5. So later on, the 10 years later, that is published on 2016. It is given by Aaron Dankla and her co-authors. They based on the satellite monitoring, model prediction, and validation of ground air monitors, and give this global map. Although the color looks deeper than the previous picture, but it doesn't mean that the total ambient pollution becoming serious. It's actually, you can compare with the lines here. It's not that the absolute level is generally decreased, but you can still see the distribution is not equal, and Asian and African areas, and they have still a lot of higher levels of PM2.5. And actually, we talk about health, and this is a picture about the global deaths attributed to level 2 risk factors for both sexes. And I try to use compare 2000 and the global deaths in 2013. So we're going to see that all the risk factors listed here, either 2 years, you're going to see that air pollution as well as tobacco smoke, and they ranked a higher top rows about for the global global health burden. Actually, the air pollution here, it's included both ambient air pollution, ambient particles, and indoor air, as well as ambient ozone was calculated inside. And if we compare, that is, previously this picture is compared on the time schedule. And if we look at geographically to give a comparison between global and for China, you're going to see that this problem becoming even serious in China, because globally going to see in the same year, 2010, for ambient particulate matter purely, the risk factors ranked around 8th, top 8 the position, but in China, the health burden is contributed at top 5. So it's really a more serious problem. So according to the evaluation by WHO, we're going to see that ambient air pollution made of high concentrations of small and fine particulate matter, it really gives the greatest environmental risk to health, causing more than 3 million premature deaths every year. So if we know about this big picture, then for our topic, it's about how about the contribution of particulate matter on health burden in comparison with other environmental factors. Maybe by comparison with other environmental factors, it's going to be easier for us to know about the particles. So actually here I use two literature. One is the very good study for the environmental burden of disease in Europe, because they assessing 9 risk factors and combining the study and data in 6 countries in Europe. So this is actually their study have get published. In their study, you're going to see that they have known about the global health burden, but their question is want to know more about how is the environmental burden of disease measures. In another word, is they want to calculate the contribution of environmental factors to the whole global to the burden health, and then to compare the health impacts of various environmental risk factors. So that's why they use their method, do a lot of calculations, and they use the dailies to indicate the health burden. And you're going to see that they selected 9 risk factors that was from benzene, dioxins, and secondhand smoke, and formaldehyde, lead, traffic noise, ozone, and airborne particulate matter, and radon. So of course, these 9 risk factors is already, why they were selected is based on a lot of discussions, and also based on their data on their health risks. Of course, on the other hand, is the health was classified according to the International Classification of Disease, the 10th revision. I didn't go through the very detailed methods. How did they do the calculations? I just here show you the results. In their study, they give and they evaluate the different contributions of different factors. And finally, they give this big pie chart. We can see in this pie figure, PM 2.5 accounted for 68% of the whole health burden. And next is secondhand smoke, and then noise, and radon, dioxin, lead, and ozone, and benzene and formaldehyde. So this is their general picture. So you can see that from the general picture, it's really for particulate matter for PM 2.5 really accounted for a large part of the total health burden. But in this study, actually, they did not really differentiate the particles, whether does it come from indoor or come from outdoor. Although we know that people spend a lot of time in indoor environment, so the PM 2.5, but it's not really clearly to differentiate it in this study. So for next one, okay. So in this study, their conclusion is that environmental burden of disease was estimated for 9 factors, and the highest overall public health impact was for ambient particles, and then followed by secondhand smoke, traffic noise, and radon. And another study, that is a second study, is from United States. And they use a method to estimate the chronic health impact of air pollutants in United States residences. So it's very interesting in this study is that they select they are concerned about the effects of individual residential indoor air pollutants. So it's specifically on indoor air pollutants. Sure, they also use the health burden disease calculations. They combine the disease incidence as well as the daily based health impact models to estimate the whole population average health costs. So yeah, there are some complex models here to do the evaluation. So the structure is that they include like 267 chemical air pollutants. So this is a list of all the compounds, chemical compounds they analyzed in their study. And 70 of the pollutants has already sufficient toxicological and epidemiological data. And you can see on the last line here, they include the common compound, for example, the PM2.5 ozone here. This is some compound we can recognize very easily, NO2 and SO2 as well. So in the first, second, and third lines, a lot of chemical compounds, organic chemical compounds. So this is some of their methods. They determine the annual population health impact, including daily losses or use a partial deviation in recognition that the daily losses are immediately affected by causes or other disease. So this is related with how to do the their disease burden calculation. Okay, results. In this study, it's very interesting that they did and put a lot of efforts to calculating the contribution of contribution for each of the compounds. How do they contribute to the dailies? You're going to see that in this chart, they are listed for the organic chemical compounds, because this is based on the daily losses and use the similar methods. And we can see that this is from the left to the right, and there's going to be a trend a little bit lower and reduced contribution to the whole health burden. And in this chart, formaldehyde and acrolein had the largest estimated number of dailies. So next chart is about the, they listed 5 of the common air pollutants, including PM2.5. So we're going to see that the estimated dailies lost because of the incidence of stroke, chronic bronchitis, and premature death due to PM2.5 contributed substantially to the annual health impacts. So we can see that these three lines are corresponding to PM2.5. And then the third chart is they combine this or either organic or inorganic compounds together. So you're going to see if they calculate the estimated population average annual cost in daily lost, and then you're going to see PM2.5 still ranked the first, and then secondhand smoke, and radon, formaldehyde, acrolein, and radon. Okay, this is for non-smokers. The first radon is for smokers, and ozone, NO2, and then followed by other organic compounds. So we can see they have given this list here. So it's very interesting to give us a relatively clear picture to if we want to improve human health, and we want to find out what is the important indoor air pollutant to save the to reduce the health burden. Now we can know their rankings of the among the different pollutants. So the black square and black dots here is indicated for different approach in doing the evaluation of the health burden. So you can see they have and in their conclusions, they think that these two methods are comparable to do this calculation. So in this study, actually, the final conclusion they give us is in United States residences for PM2.5, acrolein, and formaldehyde really dominates the health impacts due to chronic exposure to non-biological air pollutants. And this is their estimate about this number of dailies per 100,000 persons. Yeah, I give you these two studies to now here is trying to I think they are two very good representative studies to tell us about the importance of the particles and their health effects in a perspective of the health burden view in this way to do the evaluation. So next is some study that's for me and also our group recently, in recent years, we did about the particles and their health effects. Some of them are we started actually from the outdoor air pollutants. We know that China, including India and also other developing countries, we are facing or we are having a relatively higher level of air pollution. And in recent years, actually in China, for PM2.5, it started to be under regular monitoring by governments since 2012. So that is till now, it's close to 7 years for the regular monitoring station. So before 2012, there's actually no regular monitoring of PM2.5. And some data in China is more about either from model simulation or model prediction, or from individual cities. They have their own instrument to do the monitoring. So that's why you can going to see more and more study focused on PM2.5 since 2012, because now a lot of data has been produced and based on this monitoring network. So this study here I showed you is about CAPES. So the full name is China Air Pollution Health Effects Study. And it's finished by our group in school in Fudan University. In this study, it's quite huge because it's included 17 cities and recruited 18 million people in Chinese cities, because all these cities listed here are either they are capital cities or autonomous cities. So they have the data per hour of the PM2.5. So at that time, firstly, actually, this study is more focused on the PM10. I made a mistake. So next one is about PM2.5 because it's already published in 2012. So in this study for PM10 at that time, that is available data nationally. We calculated for the total mortality, cardiovascular deaths, and respiratory deaths based on the time series study. And you're going to see that for different cities, this is a different city's name, and the last one is a national average. You're going to see that the national average for total mortality, there is a very significant relationship between the PM10 and total mortality, as well as for cardiovascular deaths and for respiratory deaths. So it's very strong signals there. So based on the pollution level in China, then we draw this curve that is to investigate the exposure response curve. This is for PM10. So actually at that time for PM10 in Chinese air quality standard, we still use 150 as the grade 2, that is the lowest grade of the standard, national standard. And of course, grade 1 is around 100 or 75, probably 75. I need to check back. But you can see, but our data can very clearly to show that, I mean, this is a national standard, but there is a lot of space and almost a linear range for the increase of the air pollution with the % increase of total mortality. So in perspective, protecting human health, I mean, the standard level must be, or is going, or needs to be lower to protect human health. So now comes to the second study. It's an even larger study, and then it's focused on the PM2.5. It's already get published in 2 years ago. So it's about PM2.5, air pollution, and daily mortality. So we concluded the study in this more than 200 Chinese cities, and now it can include the data from 2013 and 15. The similar method is also focused on the health effects of daily total mortality, as well as the specific disease, CVD, hypertension, stroke, and respiratory disease, and COPD. And you can see that the whole Chinese map here was putting 6 regions from northwest, northeast, and east, middle, south, and southwest. So I just jump directly to the conclusion is that the result is one of the major results is based on these studies. We draw the national average exposure response relationship curve between 2.5 and the total mortality. You know, before this data, before the regular monitoring network setup, it's very hard for us to really find out the exposure and response curve in the current pollution levels. So now it's based on this curve, it's very interesting to see that there's a very, very deep and very straight line under 15. That means in the lower level, and then it reaches to a relatively flat, stable, platform, something like this. But it's so the current level for PM 2.5 actually it's the national level average level is decreasing and decreasing. So last year, in some cities, for example, in Shanghai, the annual average of PM 2.5 is less than 30 micrometers, close to 36. Less than 40 is close to 36. But some other cities, for example, in Beijing, they are between 50 to 60, so somewhere here. So it's very hard to see a national level over 100 nowadays, but you can going to see even in very low level of PM 2.5, the percentage increase of the health effects for every unit increase of PM 2.5 is very large. So this is a curve based on this study in different areas, because in China, north and west and east and west, north and south, they have different climate and also different economic development levels. So in order to find out more clear of the different patterns in different regions, so this curve was made out. Generally, a similar pattern can be observed with the increase of the pollution levels. There's going to be increase of the relatively health effects, but in some areas, it's not always always linear. For example, in north, it's going to be a very deep in the lower levels, but then it's then it's a very high high change, very obvious change, and then to the other directions. But for example, in east, it's something like relatively flat, so it's somewhat different, and there are very detailed discussions in the papers about the differences between different regions of this curve. So the major contributions of this study is that we found the coefficient of the exposure response relationship in China. And if you look at the coefficient level, the absolute level in China was now looking lower than in Europe and North America. But there was a leveling off in the exposure response curve at very high concentrations in most, but not all, Chinese regions. So I don't think this lower than the Europe or North America I don't think it means that the risk is less. But there are a lot of discussions in this point. One thing is that first, the general pollution level is different in Europe and North America. So maybe the average response relationship we observe in China, or maybe in areas with higher polluted levels, they are focused on the higher levels. You know, they are focused on this level. But if you look at the Europe and North America, their air pollution level is more focusing less than 20. So this per unit change of the health effects, in number, it looks like higher. And furthermore, this association were analyzed because we found that it's more stronger in cities with lower PM 2.5 level or higher temperatures. This is also actually consistent with our previous studies and also with other studies from other regions and countries. in the susceptible populations with older age or less education, they showed higher risks. So till now, it's I use some international studies as well as the study from our group to showing a generally big picture about how the PM 2.5 inclusion on the health burden or their health effects. So next, I'm going to show you some intervention studies. So this is about random controlled trial intervention studies we have performed in China, because why we did this intervention is also based on the concern that how could we provide scientific evidence for people here who are going to be face a relatively long time of air pollution, and although the government has already done a lot of things to control the air pollution, but probably in a short time it will not decrease rapidly. So we need to take some measures to protect the health. So first thing we thought, it's a relatively economic and affordable way is to wear the respirators. So that's why we designed and thought to do a test about wearing particular filtering respirators. Does it really matter something, or does it really can protect our health if people wear the effective respirators? So that's why we do this study. Actually, we test the fine particle preventive respirators in the market. We just buy the respirators, and also we did the test for each volunteer when they have the when they wear the respirators. Do they really does the respirator can really fit with their face? So that we need to make sure the respirators are seal or very fit to their face. So this is a test about to see how does whether the respirators can really fit their face and very sealing. It's not with no air leakage.
How are you,
yeah. So the design is to ask the volunteers. They are from the medical school in Fudan University. So they were asked to wear the respirators to spend 2 days, actually as normal. But during 2 days, they were asked to walk around the streets, walk around the surface for 2 hours. So it's a kind of exercise, and these are traffic roads, and they have higher traffic pollution. So actually, we did the test during their exercise, during their walking, and as well as the I'm sorry, just 你上课就行了，那是上课的电话。I'm sorry, it's the daughter's some problem. So ask them to walk 2 hours during the 2 days intervention, and all the other time they can just stay normal as they are in their normal life. And it was done in winter season, so we asked them to wear the respirators as much as possible, even stay indoors. In indoors we do not have the effective air filtering measures. So if they can wear it in indoors, it's going to be better to lower their exposure. And this is outdoor, so we can see that this is a time proportion of wearing respirators. So in outdoors, almost they wear the respirators all the time. In indoors, there's a relatively lower time of wearing the respirators, but it's acceptable for us. And on the other side is the self-evaluation of comfortability. But this is also one of our concern when they wear the respirators. Probably it's not a very good. They do not feel comfortable with the respirators all the time. That's why we asked them to give us the how is their fitness and comfortability. Yeah, I did not go through the detailed methods, so now it's the results. When we finish this intervention study, yeah, okay, 2 groups of people. So this is a group of people, when they do the intervention. So on the other hand is another group, they just behave as normal. And after 1 week of washout, these 2 groups of people, they exchange their roles. So that means that every volunteer, they at least going to be with or without respirators. So, and then we compare and calculate the differences of these indicators between the groups with wearing respirators or no wearing. So the health indicators we measured included heart rate, blood pressure, and heart rate variability. So going to see that for heart rate variability is actually, if they have a higher heart rate variability, it's an indicator of a relatively better autonomic heart function. And there are also lots of different indicators to calculate heart rate variability. So you can see that the significant differences here is including the high frequency power and also the low frequency to high frequency ratio, and another indicator called PNN 50%. It's the full name is very long here. And we did found that their heart rate variability increased, indicated by increased heart rate, high frequency power in the groups wearing respirators. And also we observe a little bit lower of the heart blood pressure in the people who wearing respirators, but it's not significant differences simply by the comparison here. So next we did the regression analysis. When you do the regression analysis, we need to control all the other covariants, including their age, gender, BMI, and also other factors. And then the health effects we calculated for blood pressure. And also the middle part is still about the heart rate variability. And the last 5 parts is we get their blood samples and then take the serum and measure the biomarkers for inflammation, and also for inflammation as well as for the blood construction indicators. So the general conclusion based on this result is that for blood pressure, there's a lower trend, or there is a lower level of blood pressure for people wearing respirators. And in addition to their relatively better heart rate variability, we can see the circulating biomarkers, there's a relatively lower level of the inflammation biomarkers, as well as the other biomarkers for the, for example, the vascular cell adhesive molecular 1. So they are usually indicators when they have a higher air pollution. So based on the first intervention study, we can see in that for a short time, health effects of wearing respirators, it shows benefits for the cardiovascular effects to protect the cardiovascular health. The second study we did for intervention is we thought about the air purifiers when people staying inside. And this is actually, we also asked the college students to ask the volunteers, because this is a dormitory room in the university here. Usually it's 4 people, they share 1 dormitory room. So we asked the 4 people together to be volunteers, and we put an air purifiers in their dormitory room. And for air purifier studies, we make it as a double-blinded study, because we can make it as a real air purifier or a sham air purifier. when you draw out the filters inside. So this is actually the study design. The participants, they gave a random group, and then they did this with air purifier, with a true air purifier or sham air purifier, and have a crossover and washout time, and then they repeat the same intervention study for another time. So you're going to see that for this study design, we can do a self-control or compare with themselves when they are used air purifiers or not. And also, this intervention is actually done in the weekend. That means everybody who's staying in dormitories for 2 days, they can have normal activities, but almost 80% of the time they are required to stay indoors. So during the intervention, of course, we need to perform the PM2.5 monitoring, and we use the micropam, and we measure their temperature and humidity, relative humidity, and also both indoor and outdoor. And then according to their space activity records, we can calculate their personal exposure. So this is a result. When we try to calculate the indoor and outdoor average PM2.5 during the intervention, we can see that for the 2 stages, that is 2 times for the intervention, this is outdoor air pollution. For outdoor PM2.5, it is very high level at that time. It is winter time. And for indoor PM2.5, when they use air purifier, you can going to see that if they use a sham purifier, the PM2.5 is close to 51. But if they use a real PM2.5, it's 90.9. And this is the second time. So if you calculate the difference between high exposure, that is a true air purifiers, or sham air purifiers, it's going to be 81% difference. This is a curve to more clearly see how is the differences. And you can see that this is outdoor, and this is the indoor without purifier, with sham, and this is indoor with real purifiers. It's very obvious of the air pollutant level and their exposure level. So next is that when we measure their exposure levels, on the other hand, is we take their urine samples and blood samples after the intervention each time. So this is based on the let me see. This is based on the serum. Okay, this is based on the blood samples in serum. We did a metabolome analysis, and we used the principal component analysis to see is there differences about the metabolites in their serum under 2 exposure patterns. So we can see that low exposure, that is with the real air purifiers, and the blue one is the higher exposure with the sham air purifiers. And we can see that either by GCMS, that is a way, or ultra HPLC MS method to analyze the metabolites. We can see very easily a difference of the metabolites spectrum in 2 exposure patterns. And yeah, this is the circle. We can see more clearly. So now we can see that under different exposure levels, people in our blood samples, the metabolites changed significantly. On the other hand, we also measured blood pressure and also pulse pressure pulse pressure is not in serum. I think some mistake here. We measured blood pressure and pulse pressure, and the left figure is about the systolic and diastolic blood pressure and pulse pressure, and by comparison with the higher exposure level, that is a sham air purifiers comparison to the real air purifiers. And on the right side is the figure to quantitatively calculate the percentage increase of blood pressure corresponding to every 10 microgram per cubic meter increase of PM2.5. You can understand the left side is about the qualitative comparison. Right side is about quantitative evaluation. So it's consistent with each other, is that by regression analysis controlling for other covariants, the blood pressure is significantly higher in the group with higher PM2.5 exposure. And also this is the quantitatively evaluation, it's the same results. And also we take their blood samples to measure the inflammation biomarkers. Because in our studies, not only in this intervention study, but also the panel studies or other short-term effect studies, these inflammation biomarkers are very sensitive to PM2.5 or particulate matter exposure. So we can see that we take 1, 2, 3, 4, 5, 6 as the representative indicators here, or almost all of them show an increased level of inflammation, and some of them are statistically significant. And also we did test for the insulin resistance in the serum samples. So we can see that still there is a high increase of the insulin resistance and the glucose levels as well in the high exposure level group compared to the low exposure. And this is about the oxidative biomarkers in the urine samples. This is in the urine samples. So you can see that generally there is increased oxidative stress biomarkers in the groups with higher exposure of PM2.5. And this is their quantitative evaluation. So actually this is, so till now, they are the main results of the intervention study of we did in our group. So first about wearing the respiratory respirators, and second is to using the air purifiers. Actually, we are trying to making another intervention study that is to use omega-3 supplement in Chinese adults, but we haven't get the clear results now. It's still the data collection has been finished, but the results has not been make it clear. Generally, I think there are actually some other very interesting study if we talk about the big picture. Big topic today about the indoor air pollution, focused on particulate matter and the health. For example, I give you some examples here. They are very interesting to either in Europe and also in United States. They give the very interesting evaluation study for the indoor fine particulate matters of the health effects, including ventilation, filtration, and also this is very interesting. They are from Canada. It's actually a randomized double-blind crossover study of the indoor air filtration in the First Nation community. And also some interesting study from the homes of elderly to how to protect the health of them by using air filtration to purify the air. And in China and also in other developing countries, if we talk about the indoor particulate matters, actually burning, biomass burning in indoor environment is also a big problem. But in our study and also the study I introduced today, they are more from urban areas. So the burning of biomass or it's not that big problem, but we know that it's still in certain areas it's still a problem and or heavy situation we need to solve in rural and suburban areas. For example, the agriculture crop, residence burning, and also coal burning and wood burning, and even the animal feces burning to cooking and also taking and warming. So this is also the study for later on we need to focus on. And thank you for your attention tonight and today. And this is our group picture. So thank you for them for their contribution for our work. So I think my topic is shared to you now, and if we still have some time, and I can get the questions.
Thank you. Thanks, Professor Zhao, thanks for a wonderful talk. And actually, it's very interesting. And you show us your groups, the study, and we all know for the air pollution, we all aware of the detrimental effect of the air pollution on the human health. But for public population, and we know how to, for individually, how we can protect ourselves, right, from the air pollution exposure. So your study give us the two easy way. One is to put on your respiratory. I'm not sure that 3M the master the respirator, is it comfortable to put it to wear it?
Yeah, when we did that study, it's actually it's not when we did the study, we choose that type of the 3M, that is the brand name for the respirators, and they have a valve to let the air go out. So at that time, in one way, it is relatively better than the other respirators which do not have the valve go out. Otherwise, you're going to feel even, you have the high pressure you have the resistance pressure when you're breathing when wearing the respirators. But later on, so it's not, if you wear it for a long time, personally, I don't think it's very comfortable. But for our study, it's 2 days. So I should say thanks for the volunteers. They really comply with our requirements.
Yeah, right. And for the air purifier, you can see there was a significant decrease of the PM 2.5. The outdoor shows the 100 microgram per cubic meter, and indoor half degrees. And with the real, the purifier, it can decrease to less than 10 microgram per cubic meter, right?
Yeah, that's true.
So that means that for most people, if in their heavy air polluted days, that they can just stay at home and turn on the air purifier. So it's the efficient way to just.
It is. Actually, there are a lot of discussions in China also. I think it's because when you use air purifiers, and when there is a high air pollution outdoors, it's very obvious to lower the particulate matter levels in indoor environment. But on the other side is that people concerned about the ventilation, because you close the doors and windows, so the ventilation is not enough. And in China, the buildings, including schools and also the common residential buildings, the ventilation, the mechanical ventilation is not compulsory, it's not required. So people's ventilation now is more based on natural ventilation. So when you close the doors and windows, the natural ventilation kindly stops. In a short time, it's good and very efficient to lower the particulate matters. But in long time, people are concerned about ventilation is not good. So that's why some people, they put forward to use the filtered fresh air ventilation system. So now it becomes discussion. The filtered air ventilation system, they consume energy a lot, and also it needs the requirement of the construction of the building's construction, because they need pipes and they need space to reinstall that instrument. Not like air purifiers, it's portable and it's easily to move, and did not occupy a lot of space. So it's some discussions in this part. But of course, the best choice is to lower the ambient outdoor air pollution, so people can really use the natural ventilation freely, and to and do not expose to higher pollution levels outdoors.
Right, I agree. And actually, for the most developed countries, the PM2.5 is not a big problem, right? But I know that the ultrafine particles actually in the developed countries higher than developing country. So do you have any ideas that the air purifier, they can have some effect on the ultra particle?
Yeah, ultrafine particles is actually very important and particularly related with the traffic. And it's actually now you can see that people are becoming more and more concerned about ultrafine particles, not only in PM2.5. And actually in one of our studies, it's going published, I think 2 years ago, we try to differentiate different parts of the size fraction of the within PM2.5. And then we found that the PM between 0.2 to 0.5, if I remember correctly, that means the particles less than PM1, PM 0.2 to 0.5, they plays the most important roles in the they are the most important part of the particles that really showing the health effects of PM2.5. So for ultrafine, it's even 0.1, right? It's 100 nanometers. I think but the data from China nowadays is not that much, and some certain groups they have already did the measurement and do calculation. But for us, we are just the start to do such things, but we haven't really get a lot of fresh new data based on the ultrafine measurements. And also because the measurement of ultrafine instruments is expensive actually. So it's we are more interested about health effects in population. So we need some, it's not measuring of the environment. We need to put them together with the people and subjects. So we are trying to collect more data in this part, but it's a very good topic.
Okay, thank you. We have the question raised by Professor Zhao Evans.
Yeah.
He said, can you comment on how the reduction in indoor exposures would improve health if a person is living in an environment where outdoor air quality is poor? In other words, they would still be getting ongoing significant outdoor exposure, but a reduction in indoor exposure.
Yeah, very interesting question. Actually, this is also our concern. For example, we did another study in school environment. In school environment is that we are concerned about the children's health. But in China, it's like that. If we install the filtered air purifier system in schools, in classrooms, so we want to make sure the indoor air pollution get reduced when they stay indoors. But on the other hand, it's for children, they need to go outdoor to sports and exercises. And also they have a 10-time break between classes. So that means when you beginning to reduce the indoor air pollution in classrooms, probably it takes 10 minutes. And then they have another 25 minutes for the class. And after 25 minutes, it's going to be a 10 minutes break. So when the 10 minutes break come out, the doors and windows are going to be open because they need to go out. So that means for them, the total exposure, combining both indoor and outdoor, it's not like as you expected that lower, that reduced that much. So if we calculate their total exposure combining indoor and outdoor, and if outdoor is higher polluted, even you install the air purifiers or filtered air ventilation system indoors, the total exposure for them is not that lower much because they cannot always stay in indoor. So so this is actually, I think, do the intervention is just, I think, just solve a little bit part of the problems. It's not a way to solve the whole situation. So the whole situation or it needs to go outdoors, and we need to remove the sources, reduce the sources, and reduce the emissions. So in that case, and combining with the improvement in indoor, probably it's better to provide a better environment for the population.
Okay, we have another question.
Yes.
From the Grill. She said, I know that air purifier can remove PM from the air, but they can also remove germs and other things as well. There's been some complaints and studies show that by removing these later items in the air, our immune system will end up being weak and without it. Do you think it's possible to have an air purifier that removes the air pollution without removing the needy germs?
I see. Thank you for the question. I think this question, well, let me see. The germs, or maybe he wants to say about bacteria, actually. We know that certain exposure to nature or certain exposure to bacteria is actually very necessary for us, particularly for children under 2 years old. They need to be exposed to nature and bacteria or certain unhealthy or unhygienic environment so that they can develop, or their immune system can be stimulated and to get improved. So for air purifiers now in China, the situation is that most of them are using the HEPA. HEPA is a high efficiency filter. Yeah, it's a kind of filter, and they are focused on the PM 2.5. So it's better to remove PM 2.5. In one way, I think it removes the germs or bacteria as well, because they can be attached to the particles, or they could be in a relatively larger particles, or and they can also be filtered. But I think the germs or bacteria for us is maybe the good bacteria for us to be exposed to is maybe more to the nature, you know, in the close to the, for example, the farming environment or more natural environment. They have a really balanced diversity, biological diversity. I'm not sure whether it is good enough to have them exposed to the residential bacteria if you're a home environment, or if buildings who situated in the very close to the traffic, the bacteria there are still good enough for us to expose to. I mean bacteria can be different in urban cities or in rooms which particularly they probably have some dampness problems, or this bacteria can grow in such an environment, and they probably are not good for us to expose to. But bacteria from nature or from a more diversity balanced nature, they are probably better for us to expose to. So it's very hard to say the air purifiers definitely can remove the good one for us. I think it depends in different situations and different cities and regions and the environment to say but it's a very interesting question. Thank you.
Okay, thank you. Is there any questions? Well, if it's not, I would like to thank Professor Zhao for a wonderful talk and the knowledge you shared to us. At last, I would like to remind you that the next coming lecture will be exposure to air pollution mixtures in an indigenous community in the heart of the oil sands from Professor Jeffrey Brooke at the University of Toronto. And thank you again, Professor Zhao, and I will see you guys next Wednesday. Okay, bye.
Yeah.